Testing. Hello, hello. Good morning, everyone. Ooh, music too loud. There we go. All right. Today, I'm going to keep going with some exorcism.io exercises. Got a few of them that are unlocked at the moment, so I want to catch up with that. Yeah. Just wanted to check here if completed, in progress. I think I had asked for mentoring. Yeah, okay. Which is probably never going to happen. It's hard enough to get those core exercises to get mentored. Those side ones are, I don't know, probably going to get mentored in like 6 years. But nevertheless, we keep coding. So I think that's in progress. All right, this one, phone number. Phone number. Ugh. Okay. Clean up user entered phone numbers. So still seems a little loud. There we go. Clean up user entered phone numbers so that they can be sent SMS messages. The North American numbering plan is a telephone numbering system used by many countries in North America like the United States, Canada, Bermuda. All NENP countries share the same international country code, 1. NENP numbers are 10-digit numbers consisting of a 3-digit numbering plan area code, commonly known as area code, followed by a 7-digit local number. The first 3 digits of the local number represent the exchange code, followed by the unique 4-digit number, which is the subscriber number. The format is usually represented as an XXX, an XX, an XX, XXXXX, where N is any digit from 2 through 9 and X is any digit from 0 through 9. Your task is to clean up differently formatted telephone numbers by removing punctuation and the country code. 1 if present. For example, the inputs, okay, I see, should all produce the output. Okay. As this exercise only deals with telephone numbers used in NANP countries, only 1 is considered a valid country code. Okay. Let's do this. Can probably just get a library on NPM and be done with it. But I won't. Okay, need to install dependencies. Phone number, there it is. Man, this exorcism folder is going to be huge because I'm installing all of the dependencies every time in each folder. I'm too lazy to set something up where you can just use like a top level node module thing. I don't know. Yeah, I'm curious. Let's take a look. I wonder how big it is now, because I have quite a few of those exercises downloaded and installed. Where did I put this thing? Here somewhere? No. In here somewhere? Nope. Doesn't look like it. Huh. Oh, it's straight in. Probably here. Yeah, that's the one. Yeah. I'm gonna need to do something about this at some point. Wow, okay. 2.71 gigabytes. Yeah. I'm gonna have to write a script to go through each folder and run npm uninstall. Or I could just delete the node modules folder. That would probably do about the same thing. But anyways, as I have been doing in the past, I will push this off to later. Now let's code. Phone number test. So we're expecting, what are we doing here? A class with a constructor and a number method. The constructor takes in our string. Our number is outputting our normalized phone number as a string. Cool. All right. 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 Let's do this. Oh, first let's just add phone. Yeah, phone number exercise. What are we gonna call this? Just phone number? Sure. Export default class phone number constructor. We're passing in a phone number type string. I don't think we'll do anything with it. Well, maybe, maybe not. Let's think about this. What's the other function? Just number. Okay. Number. Doesn't take any parameters. Nope. So the question is, where do I want the, what do I want to store in my phone number class? Yeah, I'll just store the input. Whenever I call number, I'll output whatever formatted. This shouldn't be too hard, right? Because we're basically stripping everything that's not a digit. So using a regex, a simple, what is it, D, I think. So something like return this dot phone number dot match, pass in the regex, which is going to be just what, D, I think. Let's take a look. My little regex thing here. Character classes. Digit. Yeah. Right. So we'll start with that anyways. Do I need that forward slash thing? I guess I do. What happens if I just do D? Right. It matches the letter D, so I need this. And now I could have, for instance, this right here. Boom. Okay. So, /D. Global. Don't need this to be multi-line. So now that will return a some kind of an array, or potentially undefined, right? Or null, right. So I guess we won't do it that way. We will do, let's call this match. And then we'll do if match, or if there's no match, just throw some kind of error. Throw new error. It's going to be no digits found in string. Something like that. Otherwise, let's take the match. Let's join it into a string and return that. So cleans the number. That should do it. Let's run our test. Yeah. Cleans number with dots. That should also take care of that. Yep. Cleans numbers with multiple spaces. That should also work. Okay. Invalid when 9 digits. All right, so now we want to start validating. So that's not going to work. And we are returning undefined is the, okay. So we're not throwing, we're just returning undefined. 9 digits, how many digits is the thing supposed to be? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's supposed to be 10 digits. So let's do if there's no match, I could probably just use a switch here. Switch, match, then let's do case, null. How does it work if I want to have like a bunch of different cases? Case, match. Oh, crap. I guess I can't do that, eh? No. Oh, well, I could do this. Case match dot length. Oh yeah, but then if it's null, it's not gonna, yeah, forget that. So let's go back to our switch, or if. So if there's no match, turn undefined, or just returned, I'll return undefined. So let's go, if there's no match, and, or, should I say, match dot length, it's not equal, what do we need, 10. For now, we'll just return undefined. That'll take care of our test case. Cool. Then invalid when 11 digits, that'll work too. Valid when 11 digits and starting with 1. Oh, jeez. Okay. Okay. Wow, gross. Gross, gross, gross. That is not the fun kind of stuff. Alright. So we've got a whole bunch of validation here. Valid when 9 digits, invalid when 11 digits, valid when 11 digits is starting with 1. Wonder if I can do all of that stuff in using some kind of regex. Maybe. I don't know if my regex skills are advanced enough. Valid when 11 digits and starting with 1. And valid when 12 digits. Well, let's see. Let's take some of these. So this should be invalid. Let's give it a try, I guess. So, okay. Let's make valid invalid. Right, so this should not match. How do I go about doing that? Matches any digits, characters. I know there's a way to match a certain amount of characters. Nope. Quantifiers. Quantifiers. Match the specified quantity of the previous token. Will match 1, 2, 3. 3 will match exactly 3. 3. So if I do, alright, if I do this, and then I go 9, oh, it's got to be contiguous. So that's worth crap. This one here is particularly going to be invalid with letters, invalid with punctuations. Well, I guess I don't need to do, well, I do. I was going to say, well, if we're missing, like I can just count the number of digits and then we're fine, but, and it would work with this test case here, but the idea is that even if we have this, you know, if somebody would do 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, and then a bunch of punctuations and stuff, or, you know, punctuations in between those numbers, I'd still extract the right amount of numbers, but it wouldn't be a valid phone number. So. Yeah. Well, that's going to be a pain. Well, let's just get this done. Not care about how pretty it gets. So we need validation. We need validation. Where are we gonna? So let's just call this digits here. Digits. No, hold on. This will be faster. Digits. Okay. Okay. So the next one is valid when 11 digits and starting with 1. So I guess this doesn't work. So this is good if it's not 10. So that doesn't work. I can't do it that way. Yeah, that is totally the kind of problem that I would never solve myself and just reach for a library. Because it's boring crap. Okay. So we need to check for how many numbers we have. We need to, let's get back in here. Nope. I just need to take a look at the tests. We need to check if it starts with 1. So if it starts with 1 and is 11 digits, we're good. Alright, so let's do that. If there's no digits, obviously it's not good. If it starts, so if digits dot, well, really I just need to validate what is good, right? So I wouldn't normally do it that way, but there's more cases where it's not good than the cases that are good. So if digits dot length is equal to, well, first of all, if digits, right, then and digits dot length is equal to 9, or, so we need an or here, digits, let me just get rid of this, alerts, there we go. So if digits and digits dot length is equal to 9, or digits dot length is equal to 11? No. Wait, what? Oh, it's not 9, it's 10, right? 10. 10 and 11. Okay, missing a parentheses. And digits 0 is equal to what? Now what? We'll always return false since the type string. Oh yeah, okay. 2, 1. There we go. So if all of that is true somehow, then go ahead and return our normalized number. And if that isn't true, then just return. Actually, I don't even need that. That's automatically returning undefined. So we're returning a string or undefined. Not all code paths return a value. Yeah, it does automatically, but okay, so fine, there. It's explicit. TypeScript is now happy. All right, let's see how far we get with all our tests with this. All right, I'm failing 1. Which one is that? Valid with 11 digits and starting with 1. Okay, I still need to strip the 1. Oh, my jeez. Right, because what I'm returning still needs to be just 10 digits, so... And that would never start with, let's see, let's take a look at our rules. N is any digits from 2. Okay, so it should never start with a 1. So if it starts with a 1, we just strip it. So return digits that, what should we do here? A simple if statement. We could show if digits 0 is equal 1, so we're checking that thing again. Double checkage. Then just get rid of it. So digits dot shift removes the first element from an array and returns it. Yep. Dot shift. And then I can just return on digits dot join. There we go. Let's try that. What? Now I'm failing 3. Expected value to equal 1, 2, 3, 4. Oh, that's just mean. No, 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 no. See, that is not right. That is not okay. See what they did there? They're getting us to... They're basically giving us an input that's not a valid phone number. Right? Because this cannot start with 1. And that's not fair. Because they're getting us to implement stuff that we have to get rid of the 1, right? So... Let's complain about this. I don't feel like it. Don't feel like it. Let's just work around it. How are we going to work around it, though? So we'll do that only when it's 11 digits. That should work. So, oh man, I need. Okay, so let's just redo this. Another check. So let's do that. That should work, right? Should fix the problem. Yep. Freaking ugly, but invalid with 12 digits, so that should be okay. Yep. Invalid with letters. Well, it's gonna pass, but like I said, it's gonna pass for the wrong reasons. Not because it has letters, but because it doesn't have the right amount of digits. So we should probably make a check for... how are we gonna do this? Const, letters, I guess. equals this dot phone number match, and we're just gonna do what is the one for letters? It's I don't remember. I don't remember. Is there one for letters? There's one for word. There's one for digit. There's one for not digit, but that would probably, forget that. And I thought for sure there was one that was just letters. Okay, what if we did, let's see. What if we did, skip the digits. Something that matches. Something that matches, let's see, A to Z and A to Z. And also, how do I make like everything, match everything except this? Is there a way to do this? Cheat sheet. Any character except new line. Not one. Any of A, B, C. Not A. Okay. So match everything except. So that would be this. So if I were to say, for instance, if I were to say this like that, match everything. Where's that thing? Here. Everything except, match everything except this, and this, and this, and this. Ah, not bad, not bad. All right. And accept digits. In that case, if I had, let's see, non-valid. So let's call this non-valid. Characters. And what's the one we're trying to try? This one, these two here. Okay, so let's get this one. Da 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 boom. Right here, so perfect. It matches the non-valid characters in there, and this, it matches the non-valid characters. This works. I believe this works. So let's copy that. And put it in here. So, if digits and non, so technically there would be no match, so non-valid characters, and blah, 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 blah. Let's try that. Oh, now what? Oh, it matches spaces, doesn't it? So if I'm taking a look at cleans with spaces. Technically want it to be valid, so a space is what's a space again? White space is S, right? So don't match white space. There we go. Let's just add that here. There we go. Let's see. All right, we're failing one. Cleans numbers with dots. Yeah, okay. So don't match dots as well. Oh, it does match it. Oh yeah, no, that's right. We don't want it to match, so. And dot. Okay. All right, we're passing this. Invalid with punctuations. Oh, and there you go. That's the kind of case I was saying that we had to be careful for. And now it's going to work. Yay, okay. But this is ugly. Whew. How am I going to clean this up? I could. Could make a, let's see. Could extract all of this. Well, more like all of this. No, let's just valid characters and digits dot length equals 10 digits dot length and digits. So let's make this. Well, I mean, it's not like it's very complicated, and we check if there's digits. We check if there's no non-valid characters. And then we check whether we have 10 digits, which which is, digits.length, pretty obvious. Or whether we have 11 digits and the first digit is a 1. That's all pretty easy to understand from just looking at the code. So once we're past that, if we have that, I could always, instead of having an AND this here, split that up into other if statements, because I already have this one here. So I could just add another if statement for 10. Yeah, that might be better than having this big long thing. So if, let's just do that. Just 10. Let's get rid of this whole thing. Length is equal 10. Cool, then we're good. We just return. Okay, actually, let's do it the other way. Actually, we can just do digits.join. Digits.join, simple as that right here. Else, if digits.length equal 1, and then digits.shift. So actually, I could just leave that blank. It's kind of dumb. If the, no. I have to return from here. Return digits.join. And then I can just do, I don't need an else, I can just do if. Return. So digits.shift then. Yep. So I think that would work. If there are digits and there's no non-valid characters, and the digits, if there's 10 digits, return digits.join. If there's 11 digits and the first digit is a 1, get rid of the 1, return digits.join. Yeah. Let's try running the tests. Okay. Uh-huh. Yeah, let's just go with that. Don't want to spend too much time on this exercise, because it's kind of boring. So add phone number solution, or yeah, solution. Let's just go add solution to phone number exercise. Ah, right. Parameter properties. False. And there we go. Let's just do this, do that, do this. Okay. Cool. Reformat code for phone number solution. Now I can exorcism submit phone number TS. Okay. There we go. Cool. Now, largest series product. Given a string of digits, calculate the largest product for a contiguous substring of digits of length n. For example, for the input 0, 1, 0, 2, blah, 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 the largest product for a series of 3 digits is 270. 9 times 5 times 6. And the largest product for a series of 5 digits is 7 times 8. Okay. Note that these series are only required to occupy adjacent positions in the input. The digits need not be numerically consecutive. Okay. Yeah, okay. For the input, all of that, the largest product for a series of 6 digits is 23520. Where do I find 235? Two, 3, 5, 2, 0. There's a 0 here, so it's got to be around here somewhere. It's the only 0. Oh. Okay, that's their largest product. That doesn't say anything. Not quite sure I understand the rules. Maybe the test will help us understand. So let's download this. We're done with you. We're done with you. Okay, npm install. All right, largest series. Let's just commit that. Add largest. What is it called? Largest series products. Product. Largest series product exercise. We are, whoo, okay. Cool. So we're expecting, what do we need here? A class with a constructor and a method called largest product. That takes in a number. The constructor takes in a string. Okay, let's set that up. Export default class series. We could call it whatever we want, but series as a constructor that takes in a what? Number as a string, really? That's what it is, right? Given a string of digits. Okay, string of digits. So let's just call it digits. Private digits of type string. Don't expect to do anything with that right now, anyways. Largest product. Largest product takes in a series length, which will be a number. Is there a better way, better naming, better? Given a string of digits, calculate the largest product for a contiguous substring of digits of length n. So we could call it substring length. Yeah, I like that. Substring length. Length, okay. That's going to return a number, right? It's going to return a number, yep. All right. So how are we going to do this? Let's take a look at the first test case. Can get the largest product of 2. Largest product of 2. Pretty sure we could use recursion on that thing. Recursion could be interesting here. Right, because what's our base case? A substring of length 1. So then all we would need to do is go through the entire string to find the highest number. Does that make sense? No, it doesn't make sense because we're looking for product. One number alone. So it needs to be a minimum of 2 numbers. So here's our base case. For let's use let's use let I equals 0. I equals 0, and then as long as I is smaller than this dot digits dot length. Let's keep going with that. And I is plus plus. So now we need to not make sense to do this recursively now that I'm thinking about it. Well, and what we really want to do is keep going until this digits dot length, as long as it's smaller than this digits dot length minus the substring length, right? Don't want to go. So, and then all we would need to do is check for, well, first get the product. So const product. How do we get the product of? What would be the best way? Using a reduce? Yeah. That could work. That could work. Right? How would I do that? How would I do that? I would do list dot digits dot split. Nope. Substring is a substring being at the specified location having the specified length. Yes. Yes. So this dot digits dot substring starting from number, starting position of the index of the first character in the string. 0 gets a substring beginning at the specified location and having the specified length. So we want it beginning at I, and it's going to be of substring length. Cool. So now that we have that, it's still a string. If we wanted to use reduce, we need this to be an array. Then we can do reduce, and then PC and simply do P times C. Right? What? Oh yeah, there's that, isn't there? So we first, I could just use a map. Or I could just do number P number C. I guess that doesn't work. Oh, right. Okay, you know what? Let's do that then. Dot map number. Boom. Okay. And we end up with a product. Cool. Now what do we do with that product? Well, we need to see if it's the biggest product we've found so far. That's what we need to do. This also looks like some kind of a reduce. Could I make this like a fully functional thing? Ooh. What would that look like? So instead of what I'm doing now, I could do I need this dot digits. Well, okay, let me just put it in. Let me put it in here. So this dot digits dot reduce. Oh, okay, no. First I would need to make it into an array, so that's cool. Not a problem. 1, 2, 3. Boom. And then I can do dot reduce. Nice. So now what do I have? I have my individual letters. And okay, let's just do P and C for now, as I always start with. And what I need to end up with is the largest product. So that's gonna need to be a number in the end. So let's first, yep, okay. Let's right away map all of these to numbers. Boom. Then I can worry about, what do I need to do in here? Let's see. I need to go through each substring. How do I do that? I do have access to the index. Don't I? I do. So let's call this, let's just call it I for now. Now in here, I'm essentially able to do what I'm doing here. I start with P. So actually, no, I also need the array. So I take the array, and now it's no longer a string, so I can't do substring, but I can do slice, right? Returns a section of the array. The beginning of the specified position of the array, the end of the specified position of the array. Too bad I can't do length. That would have been simpler, but so I start inclusive at I. Then okay, so I need to start this thing with actually, it might be easier if I don't do my map here. If I just do minus infinity, let's say, okay, and then I do then A is a string now, right? Okay, so then I can just do, oh, but it's an array of string. So either way we're screwed, aren't we? So, okay, let's go back to what we had, since we have to do it that way anyways. But yeah, this should start with minus infinity. Okay. And then slice I all the way up to I plus substring length. So we're slicing that. So we end up with our substring. Well, it's not. Oh yeah, no, that's going to be a problem, right? We do need that to be a string. So yep, let's forget about that here for now. Hold on. What do I get here? I have an array of numbers. Okay, that's cool. No, I can deal with that. So we're going to call that series. Series. That's nice. Substring length. Okay, cool. And then what would I do? with that series. With that series, I would do what I'm doing right here, which is reduce. And then I need to be careful with this. Call it previous and current. And then previous times current. Cannot find previous. What? Oh yeah, sorry. Let's do this like that. And this would give us our product, which we're going to return. And it will be stored here. So no, we're not going to return it. We first need to check. So product const product is equal to this. Now we check if product is bigger than P, then yeah, go ahead and return a product. Otherwise, just return P. Right? Let's do that. Get rid of this. Like that. Boom, 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 boom. Yeah. Yeah. Yep. C's never used. We never use C. Oh, that's interesting. I guess not. Because we always use the index instead. But it's not like I can just delete it, can I? Nope. I could do this, maybe? Yeah, okay. Well, I think that would work. We avoid for loops. So we've got a reduce inside of reduce instead of a reduce inside of a for loop. This could easily be made into a ternary instead. But anyways, before we start going into refactoring and stuff, let's just make sure that the algorithm is sound and we're getting the result that we want. Because that's a lot of code without testing. npm test. Whew, okay. That's because I'm not returning this. Right. Hey. What do you know? All right. Works for a tiny number. Let's try that. Yup. Can get the largest product of 3. Can get the largest product of a big number. Haha, no, that's going to be a performance thing, right? Well, that was pretty quick. No problem there. Return 0 if, I guess maybe if you did this recursively or something, it would be a problem. I don't know. Return 0 if all digits are 0. Oh, that's going to be a problem. Oh, I guess not. Oh, right, because, yeah, it's not a division. It's a... Cool. Return 0 if all spans contains 0. Returns 0 if all spans... Oh, right. That should work, I believe. Oh, maybe not. Interesting. Received 81. Huh. So we're looking for the biggest product of 3. 9 times 9 is 81 times 0 should automatically be 0. No? 9 times 9, 0. Yeah. And then 0 times 9 times 9 is 81. That's the problem. 0. Hold on. 0 times 9 times 9. Zero times 9 is 0. And that times, that's interesting. How am I doing this? All right, let's go back to, what's our previous year? Our previous is just the first one in the series. Previous times current. All right, I gotta see this. No, where's that thing? No parameter properties. Bolts. Let's get Quokka. Okay, const series equals new series, and we're passing in this thing. Okay. Oh, it's got to be a string. And then series dot largest product of 3, I believe. And I'm getting 81. All right, let's see. Let's see. What actually happens here? 0, 0, 0, 81, 9. That's interesting. So I'm basically going, oh, that's our problem. Crap. I gotta put a stop to that. Yeah. Okay. So I need to how do I just stop a reduce? I don't think there is a way to stop a reduce. At a certain point, it really has to do the entire thing. So that's one thing I didn't take into account. Which would really make us do like a lot of extra work. All right. right. Well. All right, let's keep going with this, but we might end up going back to the for loop. So we need to do if I is bigger or equal to a dot length minus substring length, that's when we would stop, I think. Right? Then we could just return P. So that's right. There's only 2 series that we can do here. We can do this, 1, 2, 3. No, there's 3 of them. We should be doing 3 of them. Right? 1, 2, 3, then 1, 2, 3. So let's forget about the equal. Let's just get bigger. There we go. If I is bigger than a dot length minus substring, then we're done. Okay, I think that works. Let's get rid of Quokka. Let's try our tests again. Okay. Rejects invalid character in input. Oh, that's interesting. Invalid input, so that's not going to work, eh? Well, how did it deal with this? It didn't throw anything. That's not too hard to do. We just need to validate. Actually, the validation happens right here in our constructor. So if digits, actually let's just do digits dot match, and match basically everything that's not a digit. So I think it's capital D, isn't it? Not a digit, that's right. So match everything that is not a digit. I could probably use something else than match instead and use, let me think about this here. That returns a boolean instead. Okay, so MDN string, not replace, just string. Okay. Includes, the method determines whether one string may be found within another string, returning true or false. Can I use a regular expression? Search string, a string to be searched for within the string. So it doesn't look like it. Doesn't look like we can. No. So that's not good. last index of match all. Oh, that's cool. Okay. Normalize. Cool. Repeat, replay, repeat. Don't remember these. Method constructs and returns a new string which contains the specified number of copies of the string on which it was called, concatenated together. What's the use case for this? Because I'm happy. Okay. Interesting. Replace search. Aha. Executes a search for a match between a regular expression and this string object and then returns what? The index of the first match between the regular expression and the given string, if not found, -1. Okay. Okay. That could, yeah. -1. Okay. Slice split starts with substring. Blah 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 to string. So maybe, so that's an option. But I think if I take a look at the MDN regex, I think there's something better. How about just test? What does that do? Executes a search for a match between a regular expression and a specified string. Returns true or false. That is more like it. That is more like it. So your regex object, then your test, then the string. So let's test. So our regex object is this. I think can we just do that? Yeah, we can. Cool. Test. Then digits. Boom. And if it's true, right? If it's true, then we just throw a new error with the message. What's our message here? Invalid input. Oops, forgot the quotes. Invalid input. And if there's no match, then all is good. Okay, I probably need a G here, don't I? Oh, no, not here, but here. Okay, let's try that. Yay. Okay. Rejects negative span. Oh. I wonder what's it gonna do. Reduce of empty array with no initial value, blah blah blah. So it does throw an error, but not the kind of error we want. So okay, so basically we're going to validate validate the substring length. Yeah, we might as well. If substring length is smaller than 0. Actually, it doesn't make sense to do it with smaller than 1, right? To do it with 0. That wouldn't work either. So let's just throw the same error. Okay. Returns 1 for empty string and 0 slice length. Oh. So, okay. So, empty string and 0 slice length, or one or the other? How does... Returns 1 for non-empty string and 0 slice length. Okay. So returns 1 for 0 slice length is really just what I need to worry about. So if it's less than 0, invalid input. If it's equal to 1, and just return 1. Is that going to work? No. Received minus infinity. Why? I shouldn't have even... How did I get to this if... Returns 1 for empty string and 0 slice length. Oh. Okay. So, got this wrong. I got this wrong. It's if it's less than 0 and if it's equal to 0, return 1. And what about when it's 1? I don't know. There's probably a test coming up for that. Returns 1 for non-empty string and 0 slice length. Okay. And throws an error for slices bigger than the number. Right. So that's, yeah. If substring length is bigger than this dot digits dot length. What am I throwing? Slice size is too big. Oops. Throw new error. Slice size is too big. Okay. And it's right here. There we go. Marvelous. I could also choose to do this validation thing, right? Let's think about this. So this one, these ones cannot happen anywhere else than other than here because we need the substring length. But this validation could also happen here. It wouldn't be that big of a deal. Although logically, we should probably validate when we're getting the input. So I think that's the right place to have it. All right, now the question is, should I go with this or should I go with my for loop that I was working on before? Let's go back to the for loop solution and see. So we've got this going. We get the product. What do we do with the product? We have to, let's get that out of here. What do we do with the product? We take the product and we check if product is bigger than largest product. Largest product's going to be here. Equal minus infinity. There we go. So if it is, then a largest product is equal to product. Otherwise, we don't do anything. Let's see. And then once we're done with that, we return, of course, return largest product. Oh. Okay, works for a tiny number. Expected value to be 9. Oh, probably because I need a smaller or equal to. Yeah, cool. All right, so which one do I prefer? I mean, in terms of performance and CPU cycle and stuff, this is, this is more optimized. I could see this check here basically happens right in the for loop header right here. I think I might end up going with this solution with the loop. I'm still using a reduce inside, which makes sense to me. can actually make this into its own function. What does this do? It returns the product. Given a substring and a substring length, actually not even, all I need is really, let's think about this here. This not just is a substring. It makes a substring. Okay, hold on. Let's just see what VS Code gives me if I extract. New method, I don't know. We'll figure it out after. So I need the index and I need the substring length. That's cool. Because I have access to this digits.substring. So we are basically, yeah, it's basically calculate product or something like that. So calculate product. So we'll call index. And this I will call accumulated current. Accumulated current. So a little better. Okay, we're getting a substring from this. Then we're making it into an array. And we're making these numbers. Then we're reducing to getting. Okay, I think that's pretty good. So product is equal this dot calculate product. Give me the I and the substring. If the product is bigger than the largest product, cool, the largest product now becomes the product. I keep going with this until we're done, and then I return the largest product. Let's run this code, and it's good. I'm surprised it's not warning me because I'm using the same name as the function, but alright, so I think I'm pretty much decided I'm going to use the for loop instead of my fully functional. It's just more understandable and it's more optimized. Can we do better? Can we do better? Well, I just said that, but now that I'm thinking about it, I could replace what am I doing here? This is basically could replace all of this, right? Or this. this is the equivalent of my, okay, we're already mapping to a number here. No. Although it's tempting to have a fully functional solution. So, all right, so that's our logic right here. We could make this, let's see. Let's try doing this instead. Oh, what are you offering us here? Nope. Nope. I could just do, let's see. I could just do product, or actually, largest product is equal to, and then I go product is bigger than largest product. If that's the case, then product, otherwise largest product. Boom. Simple enough. Not a fan of, and I've said this before, not a huge fan of ternary statements. But, you know, when they're simple like that, they can save you an ugly if statement. Largest product is equal to the bigger of product or largest product. It's pretty easy to understand. See if that works. Didn't break anything. There we go. Pretty neat. Now the body of my for loop only has 2 lines. And once we're done, we return the largest product. Now, we could probably encapsulate all of this into some sort of validate substring length, you could call this. Fix unnecessary semicolon, fix all auto-fixable TS-lint failures. Yes, please. But that's not what we want. Huh. Doesn't give us a chance to extract this. That's interesting. Why not? What if I just did the one? Yeah. Interesting. I'll do it by hand. Oops. As per the convention I'm following. Private validate substring length. Okay. And what do I need to pass in here? I need to pass in the substring length. Just going to be a number. And then all I pretty much need to do is copy this in here. right? Then all I need to do is this dot validate substring length, pass in the substring length, and we're done. Not all code paths return a value. Yeah, that's true. And we're kind of fine with that. Just void, I guess. Oh, crap. Okay, that was our problem right there. Ah, I missed that one. Okay. Back to the drawing board. I could, let's see. Well, these two are throwing an error, so these two could be extracted. There we go. Validate substring length. Okay, that's good. And then that's pretty much the only thing we can do. Because if we tried to extract this, then we couldn't call it from there. Unless nah, let's keep it that way. Yeah, let's keep it that way. All right, let's test this. It passes. It's not bad. This should perhaps be different because we don't know what that is, you know. This whole thing could be extract to method. Validate digits. Sure, let's go with that. That's good. Run. All right, I think that's good for me. Let's add solution to largest series product. Exercise. Like that. And exorcism. Submit largest series exercise. No. Largest series product. .ts. That should work. Yep. All right. Let's just make sure that it did. Don't need this. Don't need that. Yep. Yay. All right. Not too bad. Mm-hmm. Not too bad. All right. Cool. Well, that's it for me. Right on time. See you on the next stream.